In relationship between the group, that is which group is the proper directing group. Disconnect it last to get the target molecule. Here thus order is important. Means suppose if you have a target molecule, the target molecule, in this case will be having two types of substituent. One is electron withdrawing, and another one is electron donating group. In such cases, you need to be very cautious which particular site needs to be disconnected first and which needs to be disconnected in the later stages, because it's all acts as a like particular positional directors. Suppose if it is electron donating group, then you know that if it is electron donating group which is present over the benzene system, it's always an ortho and para director for the incoming electrophile. Similarly, if you have an electron withdrawing group like this kind of system over the benzene system, then the electrophile prefers to attack over the meta side rather than over the para and ortho position. That's why you should know the nature of the group which is present over the benzene system, whether it is electron withdrawing or electron donating group. If it is electron withdrawing group, the electrophile prefers to attack over the meta side, and if it is electron donating site is already present, then the incoming electrophile prefers to attack over the para or the ortho position. So suppose if it is ortho position is sterically hindered with the already presented electron donating group, then it redirects the incoming electrophile particularly to the para position. So for that, you need to know the information regarding the nature of the substituent. Then you need to cleave the either CC cleavage or particular this CC cleavage. There are two paths one can propose particularly for this kind of target molecule. One is if it is path A, then in the path A, try to do the disconnection particularly at this junction. Then you will get a path A wherein the negative charge synthon, along with that the positive charge synthon. After proposing the synthetic equivalent for these two, can we reconstruct this target molecule is the question. So because it is an electron withdrawing group, and even though if you have in corresponding alkyl halides, so with the help of Friedel-Crafts alkylation, so can we reconstruct this target molecule? Because as it is an electron withdrawing group, even though the positive charge electrophile won't go and attack over this particular position, because this is a meta director, this group, so it prefers to attack over the meta side. After the reaction, you won't get this kind of product. Instead, you will get a meta substituted. That's why you try to avoid this kind of synthons or synthetic equivalents. Then path B, suppose if you follow the path B, then it's like one is donating group, which is already present, and along with that negative charge synthon, and along with that you will get an acetyl chloride. So acetyl chloride, and if you try to do the further disconnection of this molecule in order to get a simpler system, so you try to do the disconnection particularly with the CC junction, and you will get benzene plus corresponding alkyl halides. So we know that alkyl halide plus benzene, if you use the Friedel-Crafts alkylation reaction, you will get this particular intermediate. And after that, if you try to do once again the Friedel-Crafts acylation, not the alkylation, acylation, then you know that the group which is already present over the benzene is it's actually ortho and para director. So if it is ortho para director, the group which is already an ortho para directing is already present over the benzene system, then it prefers to this incoming electrophile prefers to attack over either over the para or at the ortho position. As it is already a sterically hindered site substituent, the first preference will be para site, and you will get the target molecule. So the examine the relationship between the group. So what type of group which is present in the target molecule, you need to examine in the first, and then you need to do the disconnection in a proper way. So which is the directing group, and whether it will, if you cleave it this particular first, then you need to think about the other group, whether it is an orthopara director or meta director. So suppose you know that this electron withdrawing group is a meta director, then donating groups are orthopara directors. Coming to the synthesis, so the starting material for the construction of that target molecule, you need to start with the benzene, then use alkyl bromide, that is 2-bromopropane, and AlCl3. The reaction name is Friedel-Crafts alkylation. You will get this intermediate, that is alkylated one. Then along with that, in the next step, you need to take this starting material, treat with the acetyl chloride, AlCl3. Then you will get the target molecule. This is the target molecule.